Welcome everyone to, I believe, the last session of the weekend. I'd now like to welcome Alexander Vaninsky on his presentation for how to kill several birds with one stone.
Dear colleagues, thank you very much for coming this evening. I understand that it's very difficult for everybody, including myself, by the way. And I want to briefly present one of my recent research that may be interest for presentation of differential equations in general. Personally, I teach at two-year community college in South Bronx and have a very diverse population, mostly people of color, Black people. And the problem is that it's very difficult for us, for faculty, to make the students interested in what we are presenting. Especially, this is difficult for such theoretical courses like differential equations. One of our problems is to prepare students to go beyond associate degree to our senior colleges. I'm from City University of New York, and our community college has dual programs that allow our students, with keeping all their 60 credits, to go to senior colleges. Some colleges may be well known, like Baruch, City, John Jay, Hunter, and so on. And also, our graduate school may be also of interest. There are some Nobel Prize recipients there. But we work at the very bottom of the system. And one of our problems is to make students interested. I want to stress how we usually teach differential equations. We begin with first order differential equations and go through separable, linear, exact, homogeneous. In our college, we first introduced solution in closed form. What was kind of strange to me that not all colleges use this approach. More often than not, they introduce a process rather than a result. And after that, we go through second order equations. After that, we always cover separable PDEs. After that, numerical methods, and we finish, or sometimes we insert at some points applications. The applications are some secondary issue in our and as to the best of my knowledge in most of ODE courses. Now, what is proposed? To introduce applications first and to stress how differential equations may be used to solve actual real-life problems and sometimes present solutions that are not evident. There are some examples. One of them I borrowed from text differential equations and boundary value problems by Edwards and Penny. In this textbook, they spent some pages about bus stop trajectory. It was first discovered in 1960s and was really breakthrough in differential equations because it covered how a rocket, say, would, starting from the moon orbit, would reach Earth. And it was very interesting that trajectory was not like ellipse or like something like this, but it contains kind of bus stop trajectory. Circle, after that, kind of part of flight, after another circle, like a bus that covers several locations. Now, and also to the best of my knowledge, it was in that paper, not in the textbook, it is not mentioned, but in the paper, original paper, that it was the first attempt to combine differential and algebraic equations. Now this is a hot topic in differential equations, but it was one of the first publications. Now, and we demonstrate this approach using economic issues. Give me 1 second. May I ask you, do you see my screen? Because I see something in the middle. I want to erase it. This maybe. This is better. Let me introduce a problem. All countries aim to reach a sustainable balance between economic development and environmental protection. And all countries try to increase output, even these are such rich countries like United States, leading European countries, Japan, Australia. But after that, they want to decrease energy consumption and mitigate CO2 emissions. No, actually, what they want to mitigate CO2 emissions and increase output. But pretty soon they realize that the way is to decrease energy consumption. And in our research, we combined these three goals together. But pretty soon, it may be found that these one and these two are actually at odds. And if we try to increase output, we need more energy and CO2 emissions increase. And it is so acute problem that modern economic studies introduce the notion of degrowth. A series of publications claimed that the only way to save our planet is to decrease output. We should not have 2 cars. We should not live in 2 big houses. We should not eat so much, and so forth. So I personally do not accept this point of view, but it gains more and more traction. What we did in our research, the list of publication is given in the end, I will give it. It suggested that if we restructure the economy of the country, then we can reach all 3 goals simultaneously. And we will kill these 3 birds together, but not only. Sometimes our short-term goals and long-term goals require different restructuring. And this research shows that these 2, short-term and long-term, can be also obtained simultaneously. And what is interesting, the most important, maybe the most important part, that one university, as I remember, is Denmark, now has a database for many economies, about 50 economies, that what is presented may use as a resource for interesting student projects. And also, there is a computer program in our language, and so interested students or faculty can do it. And by the way, after that, they can compare several countries and see how these countries can cooperate. Say, if they need to shrink different sectors, they can combine their efforts. And if they need to enlarge several sectors, they want to think about working in cooperation and sharing the world market. Now, very briefly about the content of this research. We consider three indicators. Gross domestic product, GDP, it's indicator of output, energy consumption, and CO2 emissions. And all of them we take as the gradient. In short term, we suggest to decrease GDP as following the gradient, energy consumption and CO2 emissions following the anti-gradient. Of course, we cannot follow three vectors simultaneously, but it is shown that always there is one vector that first is located in their cone and also makes acute angles with each of them. One more interesting property is that we cannot take actually gradient or anti-gradients. We need to take their projections on a condition that total of all shares in any economy equals to 1. Usually when I teach, I show my students my fingers. And let me. Okay. No, you can take your fingers your own. It's thumb, pointer, and middle, and you see that whatever you possess there is always one vector that satisfies the conditions. It is in their cone and makes acute angle with each of them. There is some mathematics, but it can be easily proved. This is the picture. One is a gradient of gross domestic product, and these two, you see, they're closer to each other, but make a large angle with them, are anti-gradients of energy consumption and CO2 production, emissions. Now, at each point, we can construct a unit vector that will decide economic restructuring of our system. There are many possible ways. This one, we can use it a little bit inclined to the right, to the left, and usually we have about 50-dimensional space, so there are a lot of opportunities. And this vector is Pareto optimal, but if we assign weights to each of these improvement of economic structure, then we can formulate a problem of finding optimal direction that minimizes, say, a total of cosine squares of angles with each of the direction. Now, all these three vectors lie in a simplex because total of all shares equals to 1. And if we combine these two pictures, this one and that one, we will see that at each point we have a lot of possible directions of structural change. And we can assign weights to each of the indicators and choose the optimal direction that we can follow, but for a very short time. No, say for a year, and sometimes maybe for a couple of months, no more. We move. At next point, everything can change, and we should choose a different direction, different. And eventually, we come to a trajectory that at each point is governed by locally optimal, in terms of our weights, direction. Maybe it is for those who love mathematics and have better prepared students. This is close to group Lee approach. Now, sometimes when we are at the boundary of this triangle, this means that one sector disappears. This cannot be, because each sector provides other sectors with something. And because of this, we need to impose some restrictions of diminishing and automatically to increase of other sectors. So we cannot reach exactly the boundaries of this triangle, and we should be somewhere more or less close, maybe not, this way. And when we reach the boundary, we should move along this boundary until we have a direction pointing to the interior. This is what theory, brief presentation of what this proposed change does. But now, it is not possible to know what the assigned weights should be. Sometimes we know poor countries should assign the highest weight to gross domestic product, and rich countries try, I don't know to what extent, but they try to put the most to cleaner atmosphere. Also, this is a problem to what extent, to how much. But this is this is a step from locally optimal to globally optimal. This is initial point. This is final point. At the final point, we can put the following optimization problem. We can put anything. We can use any functional defined on a trajectory. In our research, we use the following: to maximize minimum improvement in all three. Here. Now, how to do it? We can use, for example, Neller-Mead algorithm that does not require anything except some computations. And we found that in about 100 computations, we can combine local optimization and global optimization. And in addition to this, on the curve, we have increase in GDP and decrease in both energy and CO2 emissions. Now, why it is important? It's not purely a mathematical problem. Local optimization corresponds to the short-term, politically motivated goals. And long-term is related to nationally important goals. We like the whole nation, like the whole region. And what was found? Not this, but similar problems were suggested to students, and we had a very high level of interest. Some students were given award, not much, but about from $1,000 to $3,000, depending on conditions. But several students just joined free they were interested and they tried to know something, to be involved. And if we have done this for several, for many, for several countries, for many countries, then after that we use artificial intelligence to show how these countries can be combined and clusterized, and how can they work together. We did our research using this data. It's wiod.org, WIOD. This database now led by Denmark University, www.wiod.org. And we used the data of Chinese economy. The time it was available for 1995-2009, though they moved ahead for 5 years. And we found interesting consequences, that if the country could use our proposals, by the way, 3 dimensions plus speed of making this change, then all of 3 can be improved by about 26 to 30%. And the most important weight should be assigned to gross domestic product. And say 1.3. 1, it was always assigned to CO2 emissions, but energy consumption for China, who is the worldwide spoiler of our atmosphere, was nothing. They did not need to do this. And what is more, China could be that period much more successful if it increased the speed of restructuring about 3 times. Now, this is a list of publications. This is the last one. And my personal interest is this program. My program uses a heuristic algorithm for solving system of differential algebraic equations with non-negativity constraints. And if there is a publication that contains this in Fortran, if somebody has somebody who can write the wrapper for our language, it will be very useful if this idea will be put in practice. That's it. Thank you very much for coming and listening.
Thank you so much for that excellent talk. That was great. I let you go a couple minutes over because we started a little late and this was perfect. Excellent. If you'd like, we could keep this room open to ask some questions, and then if not, or once we're done, I think there's a 15-minute get to know each other sort of thing after this to wrap up this conference. But yes, if there are any questions, now's the time.
I'm ready and will be happy to answer any question. If somebody has them later, please email me.